Welcome back, all students, and this is a new session from the soil mechanics online class. Um, I just want to be in the same uh, level of the previous lecture. Remember, we have in the previous lecture we have stated the theory of the permeability and seepage and boiling seepage and a flow net of the water through the soil layers. Okay, today I'm going to talk some experiments. Let me give you another, let's say, review for the um, for the flow net. Um, the as you remember, here was the mostly the flow net principle. Actually, the flow net is, or the seepage is the motion of the of the water. The water will go through this sheet pile. This is called sheet pile, and this is a barrier. The barrier means it holds water not to go this way. So this is upstream. So whatever we have a sheet pile or a dam, sometimes we are using dam to hold water in this part, and this is the downstream, and due to the difference in the pressure, as you know, there is a head of water here is H1, and the head of water here is H2, so the difference is that delta H. So as much as you have more difference delta H, there will be the pressure on the water, on this soil from the water, so that if the soil is having due to the permeability and the soil, it will go from the left to the right side, and the principles of called flow net. So these are the flow pipe lines, and usually these are it's called flow channels. So it looks like we have channels. Channels means like a pipe that letting the waters going in. So when the water is going from this side to this side, it will follow those pipes. One, two, three, four, five, six. So we have six channels. Six channels. One, two, three, one, two, three, four, five, six channels. So these six channels will be allowed. Let's say it will act as a channel to let the water go from the upstream to downstream. Now, upon this flow, there will be pressure on the soil, right? So different points, different elements in the soil, they have their own pressure. And this pressure will be having those points that is, they have some of the points that have the same pressures. These points are called equipotential, equipotential lines. Those points are having the same pressure. Those also. So we have lines that representing the those are the lines that's representing the pressure lines, and they are called sorry they are called equipotential lines. So as you can see, the relation between the pressure line and the equipotential line and the flow lines is that the intersection, they have 90-degree angle. It means these are like, it will like a cube. Okay. Now, what I need from this figure is to calculate the seepage. What is the seepage means? What is the flow? The flow that will reach from this side to this side. So the flow, which is the Q, is usually is equal to K. What's the K? K is the coefficient of permeability times the delta H. What is the delta H? The delta H, it means the difference between the head of the water, this is the water part, minus the water part. It means the difference between those two levels, delta H, and times the number of the flow channels divided by the number of the drops. As I maybe yeah. So NF is the flow channel number of the flow channels. Now, how many channels are there? 1, 2, 3, 4, 5, 6. So there will be 6. And the drops means by the steps, how many drops will be those delta H will reach here. So you have to calculate the number of the drops. It is the head here and the head here. So how many steps there will be a drop in the pressure. Now for this one, like you have to calculate that's the first, sorry, the first drop is here, 1, 2, and 3, and 4, and 5, and 6, and 7, and 8, and 9. So drops will be like this, number of drops. Number of the flows will be like this. Okay. Now, based on this one, that is, we can calculate the Q, which is the meter cube per second per meter length of this sheet pile. It will tell us that how much is the water will flow from this side to other side, like this. Look at this. This is a critical condition. This critical condition, it's called boiling, boiling, and this phenomena is called piping. Piping means the water is going to have like small pipes for uh, and if we reach this one, it means that this sheet pile it's about to be failed. Okay. Now look at this small example. Based on this example, you can find the depth of water in this part is called H1 is 5.6 meters, right? And the depth in the downstream is how much? 2.2. So that means this sheet pile is acting as a barrier to not let the water go this way. But there is a flow. It says there is a small flow because there is a water in a downstream 2 by 2.2 meter depth. Now we need to calculate how much is the flow is going this way. So remember that in the upstream and in the downstream, in the upstream head, here is the H1. And in the downstream, H is depth of water is 2. So delta H, or this H, or sometimes it's called delta H, is equal to 5.6 minus 2.2, which is equal to 4.4 meter. Is that clear? So I'm trying to apply this equation. Q is equal to K times delta H times NF over ND. Okay. Now tell me what is the number of the flow channels so we have. Can you tell me that? This is channel 1, that's channel 2, and this is channel 3. So the NF is equal to 3 channels. Now for the drops, we have to use to see from upstream to downstream. So how many steps you need to will be dropped from here? That's 1, that's 2, that's 3, this is 4, that's 5, that's 6. So ND means the number of the drops is equal to 6. Is that clear for you?
All good, doctor.
All good. Now it's time to calculate the Q. The Q is equal to, we have to have the K. Here's the K, permeability coefficient. It is equal to how much? 5 times 10 to the power minus 5 meter per second. As you know, permeability is having the dimensions or the units of the velocity. So it is 5 times 10 to the power minus 5 meter per second. So to calculate Q, it's equal to the delta H is equal to, sorry, first of all, K. K is 5 times 10 to the power minus 5 meter per second. Times the delta H, that's the difference between those two ones, is here 3.4 meter. Look at this one. That's times the number of the flow channels that we have is 3. Divided by the number of the drops that we have, 1, 2, 3, 4, 5, 6. And this way will give us the flow. Can you calculate that for me? Anybody? That's 3.4 delta H, K.
وان 1.7 ئەگەر دکتۆر ڕوشیان 5 کەڕەتی دەبتوانی ناقسان 5.
بله.
دکتۆرە بێ بکاتە 8.5 کەڕەتی دەبتوانی ناقسان 5.
واقعت؟
پێوا بکەم.
عبدالله ده اسم من سابقی. 5 times this is the K. 2.5 is 2.5.
بەڵێ واکە.
چەندەکە؟
8.5 کەڕەتی دەبتوانی ناقسان 5.
متر، ما متر per second، متر بيبقى شي متر سكوير per second. طبعا Q خو already Q چیه؟ متر cube per second. پس بولی بوا متر سكوير because it's for only 1 meter of the sheet pile. 1 meter. اگر او sheet pile 10 متر بوایا او كاتا Q كمان چیه كد؟ capital Q كاتا small q ضربي the width of the sheet pile أو بالضبط متر كيوب per second يعني. باشم. Sometimes the assumption here is that all those three they are regular channels. يعني وقبل سيبوري تاز سيبوري تبهر كان diameter هبه. باشا بويلر ضربي سيمان كن. NF NQ NF كمان سيم. بلام sometimes this is because that's 90 أما 90 أما تقسيميكي بقدر أما تقسيميكي بي تقسيمه وام جاري وأجر سری که ممكن توصل irregularity كده أجر ما بي به ما L به لقل بي over L لقي أم بقدر بي over L أم نابت لو تش أم يعني كم تربية بويا لرا ما بلين يق أما دو ما بدو نيو يعني 2.7 بويا دائما بي over L functioning data related to this ones. Okay. Let me give you another example. Look at this example. That's what I told you. Here h is 5.6 and here is h is equal to 2.2. So h or delta h here same as previous 5.6 minus 2.2 and it is equal to how much? 3.4 meter. Okay. Now the number of the flow channels that we have here is 1, 2, 3. Flow channel is 3. This equation, here's the permeability is here is how much? 5 times 10 to the power minus 3 K of the soil is 5 times 10 to the power minus 3 centimeter per second, which is equal to 5 times 10 to the power minus 5 millimeter per second, same as previous example. Now, how to solve this one? We have to, if I wanted to be precisely calculate the Q, we don't have, this is a channel, it's B and it's L. This is a channel, it has a B, B means what? B means width, L means length. Now for this one, so we have B, we have L. So because this should be in scale, we have to use ruler and to calculate what are those values. For channel 1, the L, the length of this channel divided of the B is 1. For the second thing, the L over B is 1, means the same distance. For this one, the L, the length is more on the B is less, so for channel C there is a 1 over 0.3. Means what? Means you have to calculate the equation of the flow will be like this. Q will be equal to K times delta H times a number of the drops, number of the flow times small n. Now this is what we'll use A1, and this n is equal to B1 it's equal to B1 over L1. It's equal to L over P plus L over V plus, let me show you the equation. Yeah. Yeah. That will be the N. Look, N is equal to B1 divided by L1, B2 divided by and B3 plus, and this way. And this way for those non-regular clock. Okay, so for our example, we have to check for this one. The length is greater than 1.0, so n is equal to 1 plus 1 plus. What is the 1 divided by 0.38? How much? Hello? Hello? Anybody answer?
Докtor 2.66.
Point?
66.
2 point? Yani
2.67 pardon.
point. So that means we have n equal to about 4 points, right? Okay. Now for this one, we have to use the equation. The equation will be like 5 times 10 to the power minus 3 centimeter per second. Delta H is delta H is equal to 3.4 times. Now the NF, we will put 1, and then this n will give you the number of the channels. So we will say 1, and NF is 4 point how much? 4.63 divided by ND. Where's the number of the drops that we have? Drops means you are going from this side to this side. By how many steps? This is step 1, drop 2, drop 3, drop 4, drop 5, drop 6. So we have NF, ND, number of the drops is 6. So here is the 6. And this way, you have to be aware this is in meters, so you have to multiply this by 100 to get centimeters square per second. That's the flow Q. 5 times 10 to the power minus 3 times 3.4 times 100 times 1 over 6 times 4.63. Point 5. 0.5 times 3.4 times 4.63 divided by 6. So the answer, I think, is equal to 1.311 centimeters square per second. Am I right? That's called the Q, sorry. Now, there is one more thing that usually they will be asking for in these kind of examples. Now, if I have, let's say this, I have, this is the flow net. When I want to use, there will be a points on the soil, like here, it's have been given to you that there is a point A, point D, and C. So usually they will be, you will be asked for what? Here, for example, point A. I want you to tell me what will be the pressure or head pressure at point A. Now, For point A, when I want to calculate the pressure, is usually pressure at A or head pressure at A is equal to pressure at this point, let's say it's here, minus this drop. Show me the losses that's coming from the flow of the pipes to flow of the water through this channel. Now, the pressure here is 5.6. We have 5.6 meter edge of water here. Here we have 2.2. So during this journey, the water or the will lose their potential by how many? By 3.4 meter, right? 5.6 and 2.2. So there will be the change, the delta H is equal to 3.4. Now this 3.4, because they are equipotential lines, means those have the same pressure. And the losses will be divided by the number of the drops. So for each drop, when I say drop, means drop in the pressure. So 3.4 is total drop. And each drop value is equal, because the total drops 1, 2, 3, 4, 5, 6. So we have 6 drops. So for each drop, it will be 3.4 meter divided by 6. That will be equal to how much? Each drop, 3.4 divided by 6. Anybody help? It's 0.6. Means what? Means when we have a point like this here, let's say this point X, at X, the pressure is, the head is how much? Is 5.6 meter, because it has a water above it, 5 point. Here at A, the pressure will be 5.6 minus the drop of the pressure. How much is the drop of pressure? Because it's one square, one step, so it is 1 times 0.6. 0.6 meter have been dropped for each one. So the head here is 5 meter. So this is the head at A. Now, can you tell me at C, what will be the pressure at C, HC? The pressure at C is also equal to 5.6 minus, because it's in the same drop, it is equal to 5.6 minus 1 drop times 0.6. The 0.6, we said it's a value of the drop. Now, it's also 5 meter. That's why we say the point C and point A, they have the same heads or equipotential line, because they have the same value of the pressure. Now, if you want to see at point D, what will be the pressure at point D? The pressure at point D is equal back to the origin. Now, this is D, right? It was, if I want to check for A, if I want to check for the pressure of D, I wanted to know how, B, HB. HB, it is coming from this side. So it's the pressure at X, which is equal to 5.6 minus how many drops have been happened till you will get the value of P. That's 1 drop. This is 2 drop. That's 3 drop. This is 4 drop. This is 5 drop. So 5 drops have been happened. So HD is equal to 5.6 minus 5 drops. Each drop's value is 0.6, right? So the pressure at D is equal to 5.6 minus 5 times 0.6, which is 3. So it's 2.6 meter. That's 3. 5.6 minus 3 is 2.6 meter. And what will be the pressure on this one? The pressure at this one will be 5.6 minus 6 times 0.6, which is 2.2 meter. Sorry, we have 1, 2, 3, 4, 5, 6. 5.6, is that 0.6 correct? Drop. The drop will be 5.6 minus 2.2 divided by 6. How much is that? 3.4, right? Divided by 6. It's 0.56, not 0.6. So that the meter per each drop. So again, if I want to see what will be the pressure at A, the pressure, the head at A, head at A, it's equal to head at X, which is 5.6, minus 1 drop. 1 drop is 0.56. So the pressure will becomes 5.6 minus 0.56 is equal to 5.04. Now, the pressure at D is equal to 5.6 minus how many drops to get the value of D? It's 1, 2, 3, 4, 5. So it's 5 times 0.56. So 5.6 minus 5 times 0.56. So the value will be 2.8 meter. Now, if I want to check the pressure at this point, for example, here, let's say I will call this Y. So what will be the pressure at Y? It's equal to 5.6 minus 6 times 0.56, and it's equal to 5.6 minus 6 times 0.56, and it's 2.24, which should be the same. Okay, is that clear, please?
Yes, doctor.
Okay, so the main point is in this kind of flow nets, you have to, first of all, you have to check whether when we have given a scale, we have to check for N. N, it means the P over L. N equal to L over B plus L over B, L1, B1, L2, B2, L3, B3. Here's the values. Okay. Now, look at this another example. This is a dam. This is a body of dam. The dam will usually be concrete dam. It used to what? This is a natural ground level upstream, and this will be downstream. So the water is going from this side to this side. Because of what? Because of the change, or because of the pressure that we have here, and more than this. What is the head here? H1 is equal to 10 meter. H2, this is the natural ground level, is equal to how much? Is 1 meter. So the delta H is the difference between H1 and H2. It's 10 meter minus 1 meter, which is 9 meter. Okay. Now, the question is, we need to know how much is the flow is going this way, from this side to this side, Q. To find the Q, we need to know, first of all, what is the NF? The number of the flow channels that we have. How much is the flow channel? Can anybody answer? Oh, what's the NF?
والله دكتور
Attribute. NF Chanika for this example. Okay. Blunt. What's the value of N?
والله 20 دكتور
احنا بس checking لين NF retail the number of the channels. اگر دخلت بيعمل لاين كان يعني معنى channel لما channel لما channel لما channel. However, what's the N?
یەکسانە بە سێ دکتۆر.
Say 1. This is
دوو
flow.
چەنەڵمان هەیە.
دكتور
جوان
شو
سيري.
شراو هذا
جوان سيريكا. أما channelك. ويا. أما channelكتر. سيري لاين كان مكا سيري channelك. channel لبيني ده. أما channelكتر. أما channelكتر. So NF أكاتا channel.
چوار؟
Sure. Okay. The ND drops. Paving. Paving
Yes.
لقى
Yes, yes.
So what will be the number of the drops? This 10 meters becomes 1 meter, right? So
Yes.
it have been decreased by a step. How many steps or the number of the drops that have been stepwise drop? Janet.
3.
No. Kale drop, a bit to say H1 K to say H2 K. H1 up chobo H2.
Okay, 三这样。
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11, 12, 13. أما هموي بيك steps out. So NF is equal to 30. Okay. Now we need to know what is the permeability. 5.3 times to the power minus 5. NF is 4 and the number of the drops is 13. So what will be the flow? The flow is equal to K times delta H. Delta H is 9. Number of the drops 13. K is 5.3 times 10 to the power minus pinch. NF here is Chanika Chwara. طبعا أو أنا means what? تقريبا channel كان BL كان يعني بقدر يقبل دبيك يدانين. أجرنا أبو باتشي أبويا بقدر يكمان داننا. So the answer is like this is equal to 14.67 times 10 to the power minus 5 meter cube per second per meter of the width of the dam. So each meter of this dam and its width, it will permit to. طبعا there are more points, for example, A, B, C, D. If I want to see the pressure at, for example, A. Pressure at A, Chanakat. To find the pressure at A, to find the pressure at A, here's A. To find the pressure at A, pressure at A, HA means the pressure at A is equal to how much? We know that again, X, this X. So the pressure at A, HEX is the how much is the depth of water on the X? تنك معناها HX at 10 meter, right? Diameter head here. Now for A, it's usually HA كاتا HX the diameter minus بچند drop again A.
شغال زايد دي دقاقي دكتور
ناقصية كي
ناقصي
شو دا ودور كمان بيك وينيا
واي
كان كمان بيتو بچند drop كمان بيتو 1 2 3 4 5 6 7 9 10 11 12 13 بس 11 drop كمان بيتو ماشي كاتا هر دروبێکی چەندێکی پێیە هەر دروپێک کاتە 9 تەقسیمی 13 یعنی چەند 9 مترمانێ 10 ناقص 1 9 متر بە هەرێکی 13 پاقلاوەتیایە کاتە چەندە کات دروپی 9 divided by 30 which is equal to 0.69 2 متر باشا استدينا head at or the pressure at A is equal to the number of the drops أكاتا چند من هي head at X ليرة دمتر ناقص بوي بقينا A بچند drop again أما دروبك أما دو drop right بدو drop again A كاتا 2 times 0.692 which is equal to كاتشن 8.615 meter. Basha. If I want to see the head at B, Kame B, this is the B. Now, I want you to tell me what will be the drop. Ranu. عشان تراني شاتو يخينا كده.
Yes.
What will be the drop at D? At B, or the pressure at B? You have to follow the rule that the pressure at B is equal to the pressure at this level. The pressure at this level is how much? Answer, please.
باش دكتور همان شتي أينيا
No. HB أكاتا بلبلة يعني وكو HX أكيد أكاتا 10 متر minus بس بتشن ليرو again B بتشن drop ليرا أم بو إيرا ما دروبك خطر مناخت أمانة drop line
The charge drop again أيوة.
so my 4 drop her drop is چنك value okay point أما her drop چنك value okay 0.692 منيا so pressure لا بيا چنك بيا at 10 minus 4 times 0.692 4 times 0.692 minus 10 it's equal to how much 7 point
outpoint توصل سيدو
ماشي Ryan ما تقصد كده بيمبلا what will be the H at C quasi this is the C C كوتو كام drop line I'm drop line ونيا كده H of C is equal to 10 ليرو minus بچند drop again C 1 2 3
5 دروب
5 هدروبي بچنكا 0.692 and that becomes 5 times 0.692
6.54
6.54 meter. Okay. And Salvia, yeah, Shakar.
جادك
Now if I wanna check for the point F, the pressure at F is equal to how much? Go F? F. So the
دكتور
rule
دا كمي
is
دا كرتي 0.6
شنكا بودي بحسابي كين ليرو ميك مدو أما سي أما تشور أما بينج أما شاش أما حو ماش أما أما دا أما يانز ونيا يانز دروب كين.
صاد
So it is 10 minus 11. هل دروب شنكا؟
0.6
So what will be the HF? It is 2.388. باشا. سيما.
بله دكتور.
So for point N.
Point in 10 minus 12 times
10 minus 12. 12.
12 up.
من ده ما ينظم الضغط. So it's 12 times 0.692. ماشي. طبعا اگر هی اوب کن او کاتچن 1 2 3 4 5 6 دروب ام و ال بقدر چه ام و ال اچ ام بقدر اچ ال و بقدر اچ ام بو because they are on the same line. Okay, the same of the potential line. It's equipotential line. Okay. Now we will continue on these examples, and there are many things we need to know. For this flowness, the main problem, or the main point that we are focusing is to find the Q. Okay, then potential heads. Oh, I make a point. There's more things we need to know. Is to know the uplift pressure, especially for the dams. These dams usually, when you have the flow under the water under this dam, so it will push the dam above, so there will be a pressure on it. You know, when I say there is a pressure, it means there is a pressure like this, and there is a pressure like so. So it means what? It means there is a lift pressure. That's called lift pressure. So we need to calculate this lift pressure because the lift pressure is very urgent. Otherwise, it will let the dams go away. Away كهليكن دامك أو بوهلكن وكبليتون دانك فريان دانيك أم دامك أك فيلر تروشبت بيلن uplift pressure. Okay, so to find this one, we need to know calculate the uplift pressure. إيش بتشبه? We need to know at each of those points the pressure, and then calculate أوك حساب ما نقول calculate the forces. Pressure يعني شيء متر أو متراني كهمانا ببيكين با كيلو نيوتن أما تكاني كهمانا ببيكين أو با pressure. أما pressure كاتا جاما H. For هر يشي كان ليرة H كي كدوزي مانو H A يعني H B أنا تشين أنا هيدن هيد صار بجامعي وتركيكي جامعي سولكيكي تشي داتم بريشر داته كبريشر داته أما بيبقى pressure distribution بيبقى force دي تشيكت صار بإريا كي دوزيتو بيبقى one force this one force is called uplift pressure والأخيرة أو force كبود وزبا it's called uplift pressure وكوا دامك هذا طبعا stability of dam or stability of the dams it should be by gravity أبيبقى أو دامك هذا it has our own weight وزنك هذا that be more than that uplift pressure OPLNT factor of safety against rotation factor of safety awake W should be more than F by how many times 2 to 3 times so we need to calculate this is called a stability that's another point we have to discuss it later for the next time and the second thing is to calculate this is for dams for sheet piles the sheet piles is like this we need to know what is the length is this length of the drop or depth or sheet pile depth in the soil معنى بزانين باش ما نشقانو يعني زيادة بيتشخينين يعني كأيش you have to find the factor of safety against boiling and factor of safety against piping أبي وأنا بدوزينو كأبي بالبيني سيبو شوار شابه that will be for the next lecture. Thank you for attending this lecture. I hope we have a good lecture. We will be continue for the next lecture tutorial.
دست خارج دكتور جان.